Mr. Beacon podcast is sponsored by Wiliot, scaling IoT with battery-free Bluetooth.
So welcome to this week's episode of the Mr. Beacon podcast. I am very pleased to have two members from the WISER systems team, Elaine Rideout, CEO, co-founder, thanks for joining us, and Logan Maxwell, and you're a director at the company, Logan, translating between technology and plain and common English is kind of how I interpret what you do. So thank you both for joining us.
Absolutely.
Thanks
for having me.
Appreciate it.
Well, so we're going to be talking about ultra-wideband, really an update on, we've had some podcasts where we talked about it in the handsets, so it's definitely getting a lot more visibility. I'm sure you're enjoying that. We'll talk about ultra-wideband, what's changed, and what you're doing with it, which, last time I looked at ultra-wideband really closely was with my friend and colleague John Moransky from NGK, and what you guys were doing, this was a few years ago, and it seemed to me that either ultra-wideband was super expensive but really cool, or there was like some very interesting things on the horizon, and you were the guys that were doing some of that work, but it was just a little early. And now we're a few years on, and so I'm really looking forward to hearing the latest from you about where the technology's at, where it's resonating, where the use cases are, and helping us parse a bit about what some of these technical acronyms mean. But before we do that, maybe Elaine, we should start with you. And can you explain a bit about who WISER Systems are? Where are you based? You're on the East Coast, are you?
Yes, we are. We're in Raleigh, North Carolina.
All right.
Downtown.
And what are things like in Raleigh at the moment? This is the first time I've been back into the office for months, and I did it because I wanted better audio quality, less dogs and teenagers in the background. So, is everyone still working from home with you guys? How are you doing?
Yeah, we're all pretty much still working from home. Logan is currently in the office, however, and so we still are, serving our customers just as we always have. When we have to do demonstrations of our network, our building is network, and so we do that from the office, and one person at a time kind of thing. But yeah, our governor still has us in phase 1, I believe.
And are your customers allowing you on site at the moment or not?
No.
Yeah.
No, for the most part, no. Our defense customers are, but most of the commercial is kind of site-by-site basis, and most are not.
Okay. Well, we should probably center this and go back to what does WISER Systems do, Elaine? Can you introduce us to the company?
Absolutely. So we are in the business of being able to do micro-location. So we work in environments where GPS and other location systems typically don't work really well. So we can locate within a few inches and track, basically, and Logan will explain the technology a little better, but we're like GPS, except we work indoors, but we have, instead of little satellites that we placed around your building, we have little small antennas. And so we can just mesh out a space, and then anything that has our little tag on it, I have a tag,
Okay.
I can show you. So anything that has our little tag on
Very
it,
small.
right where it is, usually, within something like this. We work really well around metal, so around metal it might be something more like this.
Uh-huh.
But we work where the Bluetooth systems and typically don't work really well. They give you area accuracy. A lot of systems are pretty much homing devices, how close are you to the nearest beacon. We are more like GPS. We give you the latitude, the longitude, and the Z-axis as well.
Yeah, that's great. X, Y, and Z. And the receivers, what do they look like? The things that are used to locate those tags. Do you have one that you can show us?
I actually do.
Fantastic.
And see, it's very small.
Tiny.
And yeah, you place these up on walls.
Yeah.
And you can hang them, or you can set them on a table. I can do that right now. So yeah.
And that's it looks like you got a USB connector on that. So it's typically so you have. How many of those would I need in order to get X, Y, and Z in a kind of a boutique store? If I'm like a sunglasses store or something like that, how many of those do I need to get down to that?
Logan, I'll let you answer that.
Well, I've been in some of those stores.
Yeah.
So our system, because it's kind of like a GPS, it uses triangulation to find the tags.
Right.
And so in any given store, you'll need a minimum of 3. To start getting a Z-axis, you'll need a minimum of 4. We usually recommend putting 1 in each corner. It is non-line of sight triangulation, which is helpful to differentiate, right? So in a typical maybe sunglasses boutique, there might be times where the tag is behind something or around something. That's okay. You can still just have 4 in the corner of that given space. If there's a larger space, say your office is a great example, where there's some glass walls and other things behind you, it might be that you still only need 4 depending on that wall construction and thickness.
That non-line of sight thing that you mentioned, I'm sure no accident, because I think your closest competitor is the Bluetooth angle of arrival, which was kind of a lot better than the signal strength based stuff that's just really kind of very zone level accuracy, as you said, Elaine.
Right.
But how is it that with your implementation of ultra wideband, you don't need the line of sight, which you typically do need with, in my experience, you do need it with angle of arrival. Why don't you need it?
Right. So there's 2 reasons. One is that we're using kind of a redundant radio location technology. We like to call that RRLT, where we're taking multiple measurements, right? And so we're not relying on a single source of information in that case. But the second and more important aspect of that is that we have algorithms that are trimming and very intelligent in the sense of being able to read very low signal to noise ratios through walls and through obstructions and still count that as true signal.
Okay.
So we're just very well attuned to reading a poor signal.
And the way that triangulation is being done is not, your readers are not giving you an angle. Unlike angle of arrival, you're not getting, we think this is at 3 degrees. What are you getting back? What are you seeing? You're getting an ID, but what's the information that allows you to do that triangulation?
It's all time-based information.
Okay. So, and what's the acronym that you would use to capture that technique?
So we use a combination of a few, but mainly it's TOF and TDOA are the main ones.
And what do they stand for?
So that's time difference of arrival and time of flight.
Okay. And
so we don't use phase differentiation or any of that.
And so how does that work? How do you what does that mean, and how does that work?
Right.
Because essentially what it's doing is giving you a distance, isn't it? It gives you,
right.
If you can measure the time that is being taken, you have the distance, and then you're essentially drawing intersecting circles, and that's kind of gives you where the thing is. But where is the timing being measured? Is it being measured on the tag? Is it being measured on a server? Is it, just give us the next level.
Yes, so the time is being measured both on the tag and the antenna. The system is configurable so that you can operate it where the timing is just configured on the antenna. And basically we can run it any which way we want, but it can be configured so it's either way. And you got it just right. Essentially we are assuming that signal travels at a constant rate of time equals distance. Our algorithms are just very intelligent in being able to tell the difference of what is a true signal versus a reflected signal versus an attenuated signal through an obstacle, barrier, wall, that sort of thing.
Okay, so the fact that there's some plasterboard in the way or a bit of wood, then the signal may get through that. It's going to be attenuated, it's going to reduce, but the timing's not going to change much. It's like...
Yeah, there's a little wiggle room there, exactly, but the timing won't change much.
Okay, so as long as the signal gets through, you're good. And what sort of bands are you broadcasting these signals at? Because that's one of the other things that impacts how these things work. The frequencies, what do you use?
Yes, so we can operate on a few different channels. In the US, we typically operate in channel 4 ultra-wideband. So it's a 900 megahertz wide band centered at around 4 gigs. And in channel 5, it's actually a 500 megahertz wide band centered around 6.25 gigs.
Okay. And so the significance of that is this is a lower band than Bluetooth, which is a couple of 3 or 4 times, 3 times higher at 2.4, and so you have better propagation. You're able to, you have a better chance of getting through the signal because you're not going like that. You're kind of going like that through the things. That's my take on it. Now, the time, ultra wideband's been around for a long time. There's a bunch of ultra wideband systems installed at BMW, and if you're making a car that costs $100,000, then you can afford a lot of infrastructure and big chunky tags. That tag looked pretty small that you were holding, Elaine. So I'm interested in, what are the approximate costs of this? You don't need to give me a quote, but just order of magnitude. How can you unscare us about the incredible cost of? Because typically, the tags were expensive, the readers were expensive, the infrastructure, getting the infrastructure in was super expensive, and because the volumes were small, then just the services were expensive as well. What are we talking about in terms of economics these days with this?
Our total cost of operating is really the lowest in the business. In volume, our tags cost about the same as the BLE Bluetooth. But when you include the installation, you don't need electricians. I mean, this whole thing is extremely lightweight. Even as a computer program, it's lightweight. When you include the maintenance, the upgrades, lifetime, the fact that we can scale up to any size, any millions of square feet, any tens of thousands of tags, it actually is the highest value at the lowest cost. And part of that is because our solution, the battery life is programmable. Your battery could last up to 10 years. Our tags are reusable also, and they can last however long. You can replace the batteries, and just if you're done having one asset tagged for this tag, use the same tag for something else. So when you look at the whole thing, we're actually very, very competitive with everything else out there, and we're actually more accurate. We think we provide, and we're portable, so you can actually take the whole thing down and move to a new location if you need to, or move it around if you rearrange your factory. So there's a whole lot of pluses there on the cost side. So
yeah, and the ROI is it's not based on one price point. Of course, if you want more accuracy with a Bluetooth solution, then you end up having to have more locators. So I'm going to kind of posit some things. You can challenge them. Obviously, there's a lot of Bluetooth chips being sold out there, and I think you get where do you get your chips from? Who makes ultra wideband chips?
So we make our own tags.
Right, but you don't make your own chips.
No. And I'll let Logan respond.
Yeah.
Yeah, so currently we are a Decawave customer.
Okay.
And as you know, they were acquired. They're still producing the chips, but we use the DW1000.
So I'm assuming that chip is probably more expensive than a typical Bluetooth chip, but I think the counter argument to that is, well, if you really need accuracy and you are going to have to be, the cost of the reader is probably just a small component of that. If I have to have 10 readers to get the accuracy that I could get with 4 readers from an ultra wideband solution, then the economics become something that you can't just compare the cost of a tag versus a tag, a reader versus a reader. It's more of a consulting exercise to add that up. But I do remember, it used to be that the cost was massive for those readers and the infrastructure. What is it that changed, that reduced the price? Did Decawave just cut the price, or what changed?
No. So we've been able to create a very inexpensive, flexible reader that doesn't include a lot of other components or logic. So we're still having to purchase the Decawave chip. The Decawave chip is still, unfortunately, a large component of the BOM, of both of our tag and our antenna. So we can get competitive at high volumes with our tags, but it does take high volumes to get there. So with the readers, what we've done is try to make them very, very, very simple. So they really are just kind of collecting information and then sending it down to the next reader. And we've made it so they can wirelessly communicate and share information, so they don't have to be wired up and synchronized in all of these complex ways. So in order to, if you eliminate that wired synchronization, if you eliminate that part of it, then you're able to create a lot cheaper reader. And so we can put up a cheaper, more inexpensive reader around the space, have less of them that in essence do more.
Yeah, and I think that was one of the, so when we were looking at sort of the guys that have been around doing ultra wideband for a long time, they were talking about laying sort of a dedicated coaxial network between the readers, and that was like, oh my God, this is going to be a nightmare. But clearly, but with that wireless communication between the readers, you're able to reduce that cost.
Right.
What are the boundaries, Elaine, maybe you can speak to this. What are the boundaries of the solution that you make? Are you making kind of a full stack solution, or you have the tags, you have the readers, and there's presumably some software that gives you where the dots are that correspond to these tags? Do you go much above that, or what's the software aspect of what you do?
So we have a very, as Logan said, it's very lean. So what we try to do is we try to offer the basics that everyone can use. What we don't do is we don't specialize our solution for, tracking cats in your house, specifically, or we actually have a customer tracking rats in the lab, tracking horses at a track. We have some really cool things happening with our tech. So we want to be that base, and then have those customized solutions built on top of ours. So really what we did is I spent a lot of time just early on going out into the market and trying to find out what does the market really want that the market's not getting. And so we limit our offering to that. And it turns out that the industry and manufacturers are very leery of cloud offerings. What's going on in the factory floor is some of their most valuable IP. And unlike many of our competitors, we give them the ability to create all their zones, create their rules, and import their data, because we don't own it, directly into their in-house ERPs. So we let them use their existing dashboards. No clouds if they don't want it. It's all on-prem if that's what they want. And we don't own or even access their data. And so we work a couple of different ways. Some of our customers actually want the dashboard. That we have many, many partners who offer that fit their industry. So we bring that partner in. Other partners are other customers. They're usually very, very large multinational corporations. They're like, we have SAP. We just want to get your stuff into our SAP. That's all we want, and we work directly with them. Okay. I'll let Logan also address this topic, because it's been a fascinating thing to see what they really want, and we try to radically address what they really want.
Okay, but I hear you. It's horizontal. It can be on-premise. It's kind of primarily API based for integration with these big manufacturing execution systems, supply chain systems, and so forth. What are the main? What are you seeing, Logan, as far as the main systems that you end up integrating with? What are you plumbed into most?
Yeah, so it's, as Elaine said, it's a kind of a mix of we're either going into a partner system that's aggregating all sorts of different sensor data, also tying into an ERP or WMS or something else, or we're going direct into a client's platform. So in those cases, there's typically an asset management barcoding system or warehouse management system already running, and it already has barcode scanning in place. And so if we provide our tag with a barcode on it, basically that tag can be scanned in and into that system. And since we're providing our coordinate data, very precise precision coordinate data, we can just update that legacy information, right? So they have a legacy barcoding system that's already in place. Instead of scanning an asset every time it moves to a new table, WISER reads that it's moving and has moved to the new table, and we send all that information to that database. So we actually typically are just linking to databases, and then that legacy system is pulling from that database. Does that help answer your question? Or?
It does, yeah. I want to go back and drill down into this battery life thing, because again, that's another area that historically ultra-wideband systems have been kind of weak on. In some cases, I remember seeing this presentation from this very different ultra-wideband company, and we're like, oh, this is just amazing, and the batteries are rechargeable. How long do they last? Oh, about a day. And I'm like, oh my God, that's like a nightmare if you're going to be tagging thousands of assets. You said that your tags can last years. Give me a bit of a sense of what the knobs and dials are, because there's no such thing as a free lunch. So how long? What are the kind of service levels, response times, refresh rates that are going to give me these different lifetimes for the batteries?
Sure. Yeah, and to make a great point. And so in that particular case where you're talking about a rechargeable one-day battery, that's likely the inverse of the system we've built, right? So where we're doing triangulation with timestamps of arrival, it's the opposite for that system. So they have basically a reader that's moving around and kind of tags that are on the wall. So it's kind of just a reverse of what's happened. So our antennas are what require power and need to be charged every day. So we use a CR2032 coin cell battery, right? On that CR2032, there are two different chirp rates on your tag. So there's an in-motion chirp rate, and then there's a not in-motion chirp rate. Both are configurable, right? There are also the time to move from the active to the resting is also configurable. It's typically just 10 seconds or so. So to start your calculations, I have moving 8 hours a day. So I'm in motion on, let's say, a singular shift, 8 hours, and I'm chirping once a second while I'm in motion. My resting chirp rate is probably a factor of 10 slower than that. We last about a year and 9 months in those conditions. So we've really put a lot of just standard blood, sweat, and tears engineering on limiting any power that's happening when the tag is asleep, right? So just if the tag is at rest, it needs to be as battery efficient as possible. So that's really where a lot of that work went into. There's really not a lot of tricks we pulled. If you're chirping half of that rate, a third of that rate, a fourth of that rate, you're going to get up to, beyond the shelf life of the CR2032 pretty quickly. We do have the ability to chirp at 12 hertz. Most folks don't use that, but if you were, you have the ability to.
Yeah, if you're tracking an athlete or someone with that precision, then obviously you're gonna, presumably it's going to be proportionate depending on the number of hours and that you want to last. Are there any other variables? Does accuracy, if I want like super accurate, does that consume more battery or not?
So there's no other kind of way to get more accuracy. Now, what you can do is if you can up your chirp rate and then filter those points, right? So that's a way to kind of artificially get more accuracy. But our accuracy is really coming from the algorithms core to the system. So we don't have to artificially inflate the chirp rates to filter them down. There is a mode that is more battery consumptive, and that is to track in 3 dimensions. Right. So, and then has an additional more calls and responses to the tags,
right,
because you're doing more triangulation, and from that you are more battery consumptive to a factor of 2 to 3x even more consumptive.
But yeah, I think, I mean, the default use case in manufacturing in my mind is you're tracking pallets. And in that case, pallets probably spend 99% of their time not moving. And so you guys are in very good shape for that. What are you tracking? You mentioned rats, Elaine. Do you literally have one of those things around the neck of the rat, or is it? I'm assuming it's on the cage, so you don't actually have it as a big fashion. No, it's on the rat. Okay.
On the rat. Yes, it's in a little backpack. It's very cute, actually.
Oh, okay.
Look at this picture.
I'll have to send you. I'm not sure I'm allowed to share the picture, but it is quite cute. It's a little backpack that they 3D printed it. Yeah.
Amazing. Why would I want to know where a rat is to a high degree of precision, or are you not allowed to talk about that?
I can't talk directly as to exactly what they're doing, but it is a research study with a research university, so I'm sure it has something to do with their poking and prodding and seeing how that changes the behavior.
Okay, so literally running along mazes and you want to know where they are in the maze, and these mazes are pretty fine grain. We're talking about centimeter level accuracy for something like that. Fascinating.
Yeah, for them that's possible because they can put 4 antennas really close in. It's all perfect line of sight, so it works well in that case.
How does the accuracy change with distance from the between the tag and the antenna? How does that work?
It's all a function of getting that signal to noise ratio. So with more distance comes more attenuation, which makes it more difficult to get proper signal over noise. So you do eventually are going to have a more difficult time hearing that signal. It's really, the algorithms are designed to try to minimize that as much as possible. So you shouldn't see much of a drop off, but eventually, instead of seeing a decrease in accuracy, you'll start seeing missed reads where you're not getting any points at all in distance.
And do you have to sometimes turn up the gain on the tag in order? So if I'm in a big box retail store where the antennas might be way up, then would I have to turn up the transmission signal strength to deal with that, or not?
So the FCC is very clear on the amount of power that's able to be put into channel 4, channel 5, and the other ultra-wideband bands. So you can't really up the gain any. What's nice about our system is the read ranges are pretty far. So if we're looking at a retail environment like a grocery store, if you were able to put the antennas in the rafters, say that's 40 feet, 50 feet, you might be able to get away with something like a 100-foot grid of readers. So that's one reader every 100 feet kind of in a grid. That depends on the shelf height, right? And what we're trying to get there is the signal out of those shelves and up into the rafters and the readers. So in an open line of sight outdoor condition, you can have a TOF TDOA system running at 200-foot distances. So you can have a wireless mesh pretty far.
Something like that.
Yeah, and of course, I would never sell an instance like that, but that's if you have kind of laboratory conditions outside, you can run it at those distances, if not much more.
And for the geeks, what is the signal strength? How many dBs are you broadcasting at? Do you have the?
I don't have that offhand.
Right.
I could. I'm sorry. If I can get it for you though.
Okay. Well, I don't think. It doesn't matter. So that's great. So let's go back and so rats is one thing, but that's probably not your biggest market. What are the trends that are driving consumption of your product?
So really, for the most part, and I like how Logan likes to put it, we're really good at tracking large metal things. Like, for example, the tools used to fix fighter jets. So you cannot have that wrench left in the wing. I think a B-2 went down once when that happened. So we literally are able to track all those tools in real time. No, it's very difficult to track around a great giant hunk of metal like, a jet. a jet airplane, not to mention inside of it. So we work on assembly lines and heavy manufacturing, but we also have some other applications, and I'll let Logan talk a little more specifically about this because he's the one inside on these plants. He's tested us everywhere from nuclear power plants where we actually work, believe it or not, even though we're RF, to we were in a baseball stadium. so excuse me. So we also have some yard management solutions, tracking vehicles. We've done a lot of tracking of time motion studies, people in postal type of packaging places. So Logan, why don't you give a few more specific examples of some of the things that you set up, some of the places where you set this up?
Sure. So
and what they're doing.
In terms of market, we don't really have the luxury of being able to kind of pick and choose what markets we're going into. So we're kind of letting the market come to us, and we're kind of responding. And we do have a lot of interest, and we have pilots with I believe 10 of the Fortune 100 companies. So it's getting there. It's exciting. The main things that people track, the use cases that have come to us that we're pursuing, can fall into a few different categories. One of them is people, right? And in tracking people, to dive in there, it can be for a variety of reasons. Mostly it's for time and motion purposes. So automating time and motion studies, you can now get quantifiable metrics on the way people move around machinery or on a shop floor, and then rearrange and redesign processes to make them more efficient, right? You'll see that we also with forklifts, but that's on people. We also enter a site where we're actually clocking in and clocking out and measuring time on and off a machine for people, and also able to mandate those breaks. So a little bit of kind of an Orwellian use case of tracking your workers in that sense, but it is the union voted for it, so they're excited to have it as well, because it cuts both ways, right? You can mandate your breaks are 15 minutes long, and that you're switching machines when you need to switch machines, right? We're also
that's
looking
interesting.
at
That is interesting. I'm fascinated by this progression that we're making from these manufacturing systems, which, they have robots, but basically people are still losing things, to an environment where eventually everything is tracked. Every tool, person, work in progress, raw material, finished goods. So that's where we're headed in my mind. But I think there's a ways to get there, and one of the challenges is this union thing. But actually, I've heard many examples where that actually has not been an obstacle, because there's benefits in terms of safety, and that's.
Yeah,
really
it wasn't in this case, but I have some other sites that are a little more tentative on doing such, that we're in talks with currently. So, in this case, they voted for it. They said, hey, this will help us mandate the breaks and help us mandate that time on machine is you're shifting. You can't do a repetitive task for too long. So in this case, they wanted to have that data as well. So
that's fascinating.
To be honest.
And it also, I think, is important to point out, they had a lot of other solutions that the unions looked at. And they really liked the fact that they did not have to give their employer access to their personal cell phones. Also, we are a very circumscribed solution. We're a micro-location mesh. So they had some say in, where is this mesh going to be set up? We don't want it set up in the bathrooms. We don't want it set up in the break rooms. And so literally they knew that when they left the perimeter of that mesh, there was no more tracking going on. They knew even if they had their badge on and they walked outside the building or even outside their specific workspace, their specific grid, they were no longer being tracked. So they didn't have to worry about, Big Brother tracking them outside the workplace. And they also had a lot of say in exactly, the times and spaces where they would be tracked.
And in what sense is the WISER solution a mesh? Is it a mesh in that you've got kind of coverage of readers everywhere, or are the signals being is the information being relayed from one node to the other?
So to go back to the my earlier point with wireless synchronization, requires that it be a mesh,
Okay.
right? So each antenna has to speak to the antennas around it to keep that synchronization.
Okay, so the mesh is the timing information, the synchronization information from that perspective. It's not the tag readings that are being relayed. It's just kind of that coordination of what time is it, and everyone has to have exactly that view of the time.
Right.
I think I see it. Okay, this is good. I just want to get some final comments on where you guys are on your journey. It sounds like you're well into production now. Can you say a little bit on your size and what, where you see the market growth and opportunity? Any comments there, Elaine?
Yeah, no, absolutely. So yes, we still are relatively small. We are right now about 13 people total.
Mm-hmm.
And although we are looking to hire,
Mm-hmm.
we're pretty much poised to enter a very rapid growth phase. We do have very big customers, and they take some time to, conduct first their demos and then their pilot tests, and then actually start to go plant by plant by plant. And so we're right on the cusp of start of moving in that direction. But we already have a couple of, ERP customers who are actually scaling the solution. So the big challenge, of course, at the very beginning was, can this thing scale? And that's what every other company was facing as well. And I believe we have a head start in that area. We can scale any number of tags, any number, any size of facility, any number of floors, that kind of thing. And so I think once we've really only been in the market for maybe 2 years with our production solution. And so once the word gets out and it's just starting to, I think the sky's the limit. I think we're going to be really rapidly moving forward and growing very quickly.
What do you see in that ramp-up time? I think for anyone that's starting up a business, and I know you've studied startups and entrepreneurship for a long time, that time to ramp is such a key element to the equation. Can you pass on a few pearls of wisdom of what you've learned in terms of how long it takes different companies to go through this prototype, proof of concept, pilot, production, ramp up?
Well, I tell you, we are one of the slowest tortoises out there. I mean, from the time I had this idea, and we had a couple engineering teams that just didn't work out. They couldn't actually realize it, to the time I actually got my current CTO with his just brilliant ideas. I was able to get the funding for those. So we're really talking 2011 was when we actually started. Mm-hmm. But the issue is, it's not just like we're making a little widget. We actually had to make an entire system. And not too many other folks were going at it from that direction. Most of the others who are working in this world was like, well, what infrastructure already exists in these plants that we can, tag onto? But we realized that the existing infrastructure, the Wi-Fi systems that were out there, would not be able to do the Internet of Things in real time with tens of thousands of things if their communications data was also on those same networks. So we literally had to start from scratch. We had to develop an entire system, network protocols, hardware, software. It has been a very long journey to be able to do all that, but that's really what you have to do to get the performance that we were looking for. And so I've just been delighted how everything has worked out, and how how our early customers have been. The feedback we're getting is really positive. I'm really proud of my team.
And what are you seeing in terms of the time it takes the customers to onboard this? How long? What's like the typical timeline? You have some innovation team from a major company, and they say, "We've looked at everyone. Congratulations. We really love the demo. We've checked your references. We want to move forward." How long does it take these Fortune 500 companies to actually deploy. And I know that a lot of this is actually nothing to do with you. It's just the way they move. But I'm very interested in what you're seeing.
Well, we have one that still 3 years later hasn't really got themselves together. But then again, we have another one that's just rolling us out in city after city. And that was only about a year, Logan, wasn't it, that they were, that's in the transit sector.
What are they tracking in the transit sector? What does that mean?
Yeah, so this is an interesting use case, and not something we thought we would really get picked up in. And like I said earlier, we're kind of just, hey, if you're going to track it, we're not going to complain. So they're actually putting tags on buses and trains. And so when the buses and trains come into the yard, they're tracked with GPS while they're driving around, but when they come into the yard, they're automatically discovered, and then they can automate washing, maintenance, and parking schedules and diagrams. So we can say, hey, as the bus comes in, hey, you need to go to parking space, R-13, and he knows right where to go. So.
Wonderful. Well, I could pick your brains forever. This is really fascinating. Congratulations on this journey, Elaine and Logan, and I wish you guys at WISER Systems all the best.
Thank you so much, Steve. It's been great to talk to you. We appreciate it.
Yeah,
right.
Thanks.
I got to ask you guys for 3 songs that you would be interested in taking to Mars. As there's 2 of you, I guess you get 6. So who would like to go first? I'm gonna ask Elaine first because
okay.
she's had the most time to think about this as I popped the question to her a few weeks ago when we first spoke. So, what are your favorite 3 songs, Elaine?
So we're both musicians, just to let you know. I would have to say something. I love so many different genres, so this is a really hard question for me. But something that would be like, represent the achievements of humanity, maybe. So that would have to be like, Beethoven's Fifth or some wonderful symphony.
Okay, Beethoven's Fifth. That's a good.
Something that would remind me of the planet, and so that would have to be bagpipes, of course. And maybe bagpipes and fiddles, which would bring the family into it. My sister happens to be a very famous Scottish musician, so I would take anything of hers and have fiddles and bagpipes.
Okay, what's her name?
Bonnie Rideout.
Bonnie Rideout. Okay, that's a great celebrity name. I can see the album covers now. So is there a particular song of Bonnie Rideout that you'd choose?
Probably Rant, because that's the pipes and the fiddles together, and yeah, she was America's national Scottish fiddling champion. So she has quite a few albums out there. And then finally, it would have to be rock and roll. I guess I would have to pick something I could sing along, and there's only one song you can sing to and never get tired of, and that would have to be the Bohemian Rhapsody. The other reason I picked that is because Logan and I sang that together at one of our trade shows. We had a karaoke booth next to us, and so we just had a blast, and that was something that we...
Fantastic. So you're both musicians. Have you, other than singing Bohemian Rhapsody at a trade show, have you done anything else musically together? Do you have like company rock out things? No.
That would be a good idea. Yeah, that's a good idea. No, we never have. No.
And what instruments do you play?
Piano for me, classical mostly.
All right. And what about you, Logan?
It's definitely my biggest hobby out of work. So I play kind of in order of my ability, I guess, would probably be saxophone, bass and guitar, and piano, a little bit of drums and a few other things, but mostly kind of the stringed instruments and saxophone are kind of my main go-tos.
Wow. So are you one of these people that like makes music and records everything, multi-tracks it and records everything yourself?
I always thought I would be that person, but I am a social collaborator. So although I have some of the technical ability to do that, I really don't feel as creative and motivated unless I'm playing with other people. So it is kind of a social thing for me.
I saw Paul Simon perform live, and was reminded that he, when he records his albums, he plays everything, but then you see him live, and he has like the best musicians on everything, and it's just an awesome thing. So, what would be your 3 songs, Logan?
I'm torn here, because if I answer honestly, I'm probably going to throw out some very obscure pieces here. And so if people want to Google, that's fine. But this is going to, so I would say in terms of my classical piece, Yo-Yo Ma, the cello player, has the 5th movement of the Quartet for the End of Time. It's a very, very beautiful, haunting piece where essentially the person that wrote it was in a prison camp in Germany during World War II. It was a Jewish composer, and so he was taken in. And so he wrote it during that time frame for the only instruments that he had the ability to write for. So there was 4 instruments in the camp, and so he wrote for those 4, and they actually performed it for the first time in that camp. And he lived, thankfully. It's a happy ending. But that is just one of the most hauntingly beautiful pieces. And so it struck me the first time I heard it, and I've kept it in my rotation ever since. So 5th movement from the Quartet at the End of Time would be my first piece. I have a very weird penchant for Indian classical music. That's kind of out there, but it's very peaceful to me. I don't know why I like it. So there's a certain performer that plays the sitar that I like. His name's Nikhil Banerjee. And he has a certain rag called Bilaskani Todi that I like. So there's a certain recording there, which again, super obscure. I know no one's going to know what I'm talking about, but feel free to Google it. It's great music.
Yeah,
and
yeah.
Then,
well, we try and play it. So if we're lucky, people are hearing a fragment of that now.
Okay, sure. Yeah. It's that one in particular is pretty foreign for the Western ear, but it's really, really peaceful if you get used to it.
Yeah.
And then for the 3rd, I'd probably do something from classic rock. I'd have to. Let's see. I'd probably like Echoes from Pink Floyd or something, one of their B-sides. I really like that. So, yeah, that's off the cuff. I didn't have a lot of time to prepare that answer, but those are the ones that are stuck with me currently.
Oh yeah, I'm listening to The Wall at the moment. Mark Maron is one of my favorite podcasters, and he's has a recent interview with one of the guitar players that toured with Pink Floyd on the Wall tour, and so I'm kind of going back in time there. Well, that's wonderful. I love hearing those. Great examples. Thanks very much.